Hello everyone. In this video we will see uh, geometry of complex number. In last video we have seen the first part where we discussed about the modulus of z1 minus z2, and that represent the distance between z1 and z2. But now in this video we will see a very important locus, that is modulus of z equal to r. Okay, so this represent circle. See, if I put z equal to x plus iota y, so this is modulus of x plus iota y, that is equal to r. So this gives square root of x square plus the y square. Modulus of z is square root of x square plus y square, that is equal to r, and finally we get x square plus y square equal to r square. So in coordinate geometry this represents circle. Center is 0 comma 0, radius is r. So you can see that this represent a circle with center at 0 comma 0, radius is r. Correct. In fact, I can write down this modulus of z equal to r as modulus of z minus 0, that is equal to r. So this whole represents circle. Okay, and this 0, that is 0 comma 0, is your center, and this represent radius. uh, Geometrically also you can see modulus. See, this is the xy plane. Okay, x-axis, y-axis. Okay, fine. Complex plane, you can say that. Then this is imaginary axis, this is real axis. Okay, this is real axis, this is imaginary axis, and there is a z. So z is this one. Correct. So modulus of z is this one. This is modulus of z. Okay, so modulus of z, z can lie anywhere in the circumference of this circle. If I say that z is lying over here, if I say that z is lying over here, if I say that z is lying over here, the modulus of z is coming to be the same. That is, the modulus of z means the distance of the complex number z from origin. Correct? So if suppose that I say that modulus of z minus z1 equal to 4. So this z1 is your center, this 4 is your radius. 4 is your radius. Okay, got it? Fine. So this is over now. This modulus of z equal to r represent a circle, center at 0 comma 0, radius is r. If suppose that I say that modulus of z equal to 2, this is a circle, center at 0 comma 0, radius is 2. Modulus of z equal to 4, center at circle, center at 0 comma 0, radius is 4. If I say that z minus 5 is equal to 4, the center is 5 comma 0. 5 comma 0 will be center. Okay, and radius will be your 4. Got it? So this is now the questions. What you learn there in coordinate geometry, all those concepts you have to represent over here in terms of the complex number. What do you learn there? You learn the two circles are intersecting circles, separated circle, touching each other internally, externally, the maximum distance of any point from the circle, minimum distance of the point from the circle. So all those concepts we will learn over here in terms of complex algebra. See, first question. So the now in complex number, you have to draw the circles. One circle, two circle, three circle, inside, outside, inside, outside. See, this first one is modulus of z equal to 2. So therefore, this z is lying on here, here. Z lies on circumference of circle. Circle center is 0 comma 0, radius is 2. Okay, we now know this. And if suppose that I say that modulus of z is less than 2, then z lies inside the circle. Z lies over here, 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 here. So this shows that Z lies inside the circle. Which circle? Circle with center 0, comma 0, radius is 2. And third, if modulus of Z is greater than 2, so definitely Z lies outside the circle. Which circle? Circle with center at 0, comma 0, radius is 2. And if I said that modulus of Z is less than equal to 2, so at that time Z lies on or inside of circle, correct? On or inside of circle, and like that. Okay, fine. Now let us start with the questions. Only thing is that you have to construct circles. Okay, rough idea, rough figure only. First question is, if modulus of Z minus pi is equal to 2, then find the minimum and maximum value of modulus of Z minus 1. Correct? Okay, how to do that? See, here it is very clear that this represent what? Distance. This represent distance. Distance of Z from 1, comma 0. Correct? Okay, fine. And this represent a circle. This represent circle with center 5, comma 0. Okay, and radius is 2. One more important thing, if suppose that I have Z plus pi that is equal to 2, then this can be written as Z minus of minus pi that is equal to 2. At that time the center is minus pi, comma 0, radius is 2. If suppose that I am having 2 plus 3 iota that is equal to 4, then this can be written as Z minus 2 minus 3 iota that is equal to 4. That is center is 2, comma minus 3. In coordinate geometry, center will be 2, comma minus 3 and radius will be 4, not 16. Correct? Fine. So these are the important point you have to take care. Correct? So Z minus 5, this is circle, this is distance. So let us draw the rough figure for this circle. Center is 5, comma 0. Definitely 5, comma 0 will be there on x-axis, and radius is 2. So therefore this is circle. If radius is 2, so therefore this point is 3, comma 0 and this point is 7, comma 0. Correct? Now Z is lying here, 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 anywhere in the circumference of the circle. But I want the distance of Z from 1, comma 0. This is 1, comma 0. This is 1, comma 0. Correct? So finally you can say that if Z is lying over here, this will be the minimum distance. So therefore minimum of Z minus 1 is, what is the distance between them? 2. And maximum, if Z is lying over here, then this distance will be the maximum. Correct? So therefore maximum of Z minus 1 is 6. Correct? Clear? Now you are observing here that the circle is lying on the x-axis. What happens when the circle is lying on y-axis? Okay, let's see second question. Question number 2. Question number 2 is something like that. Okay, phi iota. I am doing it phi iota. Correct? If modulus of Z minus pi iota is equal to 2, then find maximum and minimum value of modulus of Z minus iota. Got it? It is Z minus iota. So this represent one distance. Distance of Z from 1, comma 0. Correct? 1, 1, 0 nahi. From 0, comma 1. Correct? And this represent what? Circle with center at 0, comma 5. Correct? Radius is 2. At this time the center of the circle lies on the y-axis. Y-axis is imaginary axis in urban plane. Okay, this is y-axis, this is x-axis, y-axis in xy plane in coordinate geometry. And in your argon plane, this is imaginary axis. Imaginary axis. So phi iota is lying there in imaginary axis, and in coordinate geometry this is 0 comma phi, correct? And in argon plane this is phi iota, correct? Got it? Correct. So now 0 comma phi, radius is 2, so this is something like that with the new pen. Okay, this is something like that. So this is, so radius is 2, so therefore 0 comma 3 in coordinate geometry. This is 0 comma 7, correct, in coordinate geometry. In argon plane this is 7 iota, this is 3 iota, and this is your 0 comma 1. 0 comma 1 in coordinate geometry, and iota in argon plane, correct? XY plane and argon plane both are running simultaneously. So therefore the minimum distance, so therefore minimum distance z minus iota, distance modulus is distance, no complex number at this time. So therefore you have to convert it into the coordinate geometry, XY plane, correct? So what is the minimum distance? This is the minimum distance. So this is 2, and minimum, and maximum of z minus iota. So maximum of z minus iota is this distance from here to here, 127. What is that? 127. What is that? 6, na? Correct? This is 1. This is, what is the whole distance is? Radius is 2. So therefore this is 4. Correct. And this is 1. So what is 7 minus 1? This is 6, na? Z minus iota. Okay. This is 0 comma 7, because this is 0 comma 5. This is 2. And this distance is 2. 2 to 4. 4. And this distance is 2. That is 6. Correct. Okay, fine. So this question is over. Now we will discuss other problems also. Up to this, we are using only one circle in the problem, and we are using that concept. Which concept? In coordinate geometry, that is, this is the circle, center is O, this is diameter, and this is the point which is lying outside the circle. This is A and B. So this PA is minimum distance of P from circle, and which is given by OP minus का R. OP minus का R का modulus, and this PB is OP plus R का modulus, and that is the maximum distance of P from circle. So this concept we have used from the coordinate geometry over here in the complex algebra. Got it? So the same way we will now discuss those problems where we are having two circle, more than two circle, interior part of the circle, exterior part of the circle, and like that. Now look at these two questions. I said that in coordinate geometry you have already gone through the concept of two circles. Two circles are intersecting, two circles are touching internally, externally touching, or they are separated, or they are concentric circles. All those concepts we will use over here. We will convert these locus of the z, which are representing actually the circle, in coordinate geometry, and we can give the answers to the questions. Okay, so simply to draw the questions. So question number 3 and question number 4. See, for complex numbers z1 and z2, there are the two complex numbers z1 and z2. z1 is satisfying this locus, and z2 is satisfying this locus, and both the locus are circle with center 0 comma 0, radius 12, and this is circle with center is a 3 comma 4, I know, 3 comma 4, and radius is 5. See, modulus of z minus 3 minus 4 iota equal to 5 can be written as z minus of 3 plus 4 iota. This is your z1 complex number, correct? So therefore your center is 3 comma 4 in the coordinate plane, correct? Fine. And radius is 5. So let's do. We will draw the circles, both the circles. This is simply the circle with center at 0 comma 0 and radius is 12. When radius is bigger, so let's draw first this circle only. So this is 12 comma 0 like that. Okay, now here radius is 5 and 3 comma 4 is center. 3 comma 4 will be the first quadrant na? 3 comma 4 and radius is 5. Already the distance of this 3 comma 4 from the origin is coming to be 5. This we all know. So therefore this circle is passing through the origin. So this is something like that. This is something like that. R. See, it will, see this is 12. This is 12. So therefore it will not cross this one. But can it touch this one or inside this circle? Let's see. See, this is the circle. If I say that this circle is touching like that, correct? So therefore exactly we will see that this will be the diameter of the circle. Center is 3 comma 4. So this is 10. This is 10. Diameter of the circle is 10. Okay. Is it true that this is 12? No, this is not 12. This is not 10. This is actually the 12 because the radius of this circle is 12. So therefore this should not be touching this circle, rather it is lying inside the circle. You got it? So therefore this distance up to this one is 10. Up to this one is 10. Correct? This is 10 and up to this is 12. So therefore the Z1 minus Z2 ka minimum value is coming to be 2. Correct? This whole distance is 12. This distance is 10. Therefore the minimum of Z1 and Z2 is 2. But when we draw this circle, you have to be very careful whether this is lying inside, completely inside this circle, or this circle is touching to this circle over here. That you can identify. See, the diameter is 10 and this distance is 12 because the radius of this circle is 12. So therefore it will not touch. Correct? And therefore the minimum distance is 2. Coming to this one. Here also Z1 satisfying this one, radius is 9, Z2 satisfying this one, this circle also radius is 4. So let's draw the first bigger circle with center at 0 comma 0. Okay, fine. This is okay, no problem. Now coming to the radius is 9, this is 9 comma 0, this is 0 comma 9 and this is Z2 minus 3 plus 4 iota. That is same, no? Only radius is changing here, that is 4 modulus. So 3 comma 4 is here. Now you know that the radius is how much? 4. So it will not passing through the origin. This circle is passing through the origin, but this will not pass through the origin because this distance is 5. But its radius is 4, so therefore this is something like that. Something like that. You got it? But now again the question comes the same. It is something like that, or it is something like, this one. Whether they are touching or this circle is inside completely this circle. Now my question is that the radius is what? The radius is 4 of this circle. Okay, and this distance is 5. This distance is 5. So therefore this distance is 4. Correct? And this distance is 5. Now from here to here, this distance is 4. Okay, 4 plus 4 is 8. 8 plus 1 is 9. So therefore, and the radius of this circle is also 9. So therefore, instead of this, actually the circles are touching each other internally. circles are touching each other internally. You understand now? So once again I am explaining you the correct figure. So this is your circle with radius 9, center 0 comma 0. This is your 3 comma 4. This is the distance 5, but the radius of the circle is 4. So therefore 4 will be like that, because if this distance is 5 and this is center, so therefore this distance is 4. So 5 plus 4 is 9. Definitely they are going to intersect or touch each other internally, and therefore the minimum distance of z1 minus z2 equal to 0. So what we are observing from the coordinate geometry, that here we are having the circle touching internally, here we are having the circle, and one circle is inside the other circle, but the in terms of complex algebra they are given the question. Let's see two more questions. Now you understand that this is simply to drawing the circles in the coordinate geometry. Whenever question is there from the complex algebra where we are finding the locus of a z, in fact it is a circle, then we will convert it into the coordinate geometry. Okay. So let's see the fifth and sixth question now. For all the complex numbers z1 and z2, there are two complex number. First complex number is satisfying this. So what is this locus? Is again a circle with center at 3 comma 0. Radius is 3 comma 0. Radius is 3. Therefore circle is passing through the origin. So therefore this is 6 comma 0. This is 0 comma 0. And z2 is, what is the center? Center will be 3 comma minus 18 and radius will be 2. Correct? This can be written as z2 minus 3 minus 18 ka I, and that is equal to 2. So therefore center is 3 comma minus 18. This is 3. Also again we want 3, that is x equal to 3 line. This is x equal to 3 line, and suppose that this is 3 comma minus 18. Correct? Got it? Observing here. Now let's draw one more time so that you can observe it properly. So this is your 3 comma 0. This is your x equal to 3 line, x equal to 3, and here somewhere, now it is okay. Okay, here somewhere we are having the circle with center 3 comma, say 3 comma minus 18. So radius is only 2. So therefore this is the circle. So the minimum distance between z1 and z2 will be this one. Correct? This will be the minimum. Now from here to here, the distance from here to here up to this distance is 18. From here to here, this distance is, radius is 3. And from here to here to here, this distance, radius is 2. So I want this distance, I want this distance. So this distance, 18 minus 3 minus 2, 18 minus 5, 18 minus 5 is, I think that 13. Correct? So the distance between z1 and z2, minimum distance is 13. Got it? Fine. And if they ask the maximum distance, so that z1 must be here and that z2 must be here, then that will be the maximum distance between them. What is the maximum distance between them? This whole distance, radius is 3, that means this distance is 6, and radius is 2, therefore this distance is 4. So 6 plus 4 is 10. 10 plus this 18. 10 plus 18 means 28 will be the maximum distance. 13 will be the minimum distance. Got it? Correct. Now coming to the sixth question. Sixth question says that, now this is interesting question. See, this is z minus 3. Z minus 3 minus 2 iota is less than equal to 2. So that represent the circle, okay, with center at 3 comma 2, radius is 2, and z lies inside or on the circle. Z lies inside or on the circle. Correct? This is what? 3 comma 2. 3 comma 2 and radius is 2, that means it is going to touch the x-axis. From the coordinate geometry I can say that this point is 3 comma 0, this distance is 2, okay, radius is already 2, therefore this is going to touch x-axis. Got it? Now you have to find out the minimum distance of minimum value of this. This is representing the distance. What is this 2 is doing here? So let's remove this 2. So I can take 2 common. So this is z minus 3 plus ka 5 by 2 ka iota. So this is what? 2 into z minus 3 minus 5 by 2 ka iota. Now this represent the distance. So what is the minimum distance? That will be the minimum distance between pole, correct? Minimum distance between this, the minimum value of this will depend upon the minimum value of this, and this is the complex number 3 comma minus 5 by 2. This is 3 comma minus 5 by 2, correct? Z lies either inside or on the circle, circumference of circle. So Z is there, okay, then only we will find out the minimum distance. So this is your minimum distance. So what is the minimum distance? That will be 5 by 2. The 5 by 2 is the minimum value of this one. So therefore the minimum value of this is 2 times 5 by 2, and finally the answer is 5. Okay, hope you understand the locus that representing the circle, that is modulus of z equal to any non-zero constant, that is positive constant, not negative, because the modulus is always a non-negative quantity. So therefore that represent circle, correct? On that concept we have solved problems.